This panel's subject is, can BIM revolutionize fabrication and installation in the construction industry? And I'd like to add a little bit of a twist to it and ask our panelists one by one as we begin. I'd like to first ask you to introduce yourselves one more time, so in case the audience didn't hear the initial introductions. Why hasn't it already revolutionized the installation and the fabrication of in projects? We'll start with Dr. Mohamed Kotb.
I am Mohamed Kotb. I'm the CEO of Dimensions International. We are an engineering service provider, and mainly I'm an architect. I'm a PhD architect. I had my PhD in computational architecture. That's why it's linked between coding and engineering. When we talk about construction, we had some of interesting projects in UAE with the main contractors and subcontractors in all disciplines like civil, architecture, ID, MEP. So we have struggled to kickstart the fabrication part of BIM utilization in construction projects. So the challenges is so much for the contractors, starting to convince the contractor himself to use the BIM models or outcome from the BIM models on his fabrication. So when we talk about prefabrication, it is another challenge. When we talk about the consultant to accept the, approve the models itself, it's another challenge. When we talk about awareness or all tier 2 and tier 3 in the supply chain about the BIM is also another challenge.
So essentially, if I understood that correctly, what you're saying is consultants not using the actual model and the contractors not really leveraging that model to either produce their shop drawings from or fabrication, to go directly to fabrication, CAD to CAM. Is that what you're saying?
Yes.
Excellent. And we'll start with Samer.
Yes.
From ACG.
My name is Samer Abudaqqa. I am the cost control manager in ECC. ECC is a well-established company. It's 42 years of experience, of innovation and engineering, and also a diversified project and long experience, especially in innovation. We tend to be very lean. We'd like to have the changes and the development. Now, regarding BIM, there's a lot of challenges. One is cost, the other one is the expertise, lack of expertise, and the contribution from the client. I will elaborate more, but that's in general.
Okay. So you mentioned a key word, it's the client. And usually when you think about installation and fabrication, we don't think about the client being involved so much in that. Someone we think about being involved in the design process, the concept, the approval of things.
You see, it's a transformational change. Mm-hmm. As the previous panels also spoke about, I think it's all related to lean management. It's one of the tools. If the client does not realize the benefit of BIM, if the consultant, the contractor, the supply chain does not realize this efficiency, wastage elimination, all of that, then it will be just a fancy 3D picture. Okay. So that's why we went through a lot of experience in ECC that we implemented it in-house just for our sake, for clash management, for model management, even for mobility, which has helped us a lot in giving the quality which we are well known for. But again, it has to be understood by everybody. This panel is very good experience of the collaboration. That it's a change, it's a transformation and change, and it has a lot of improvement. And like the gentleman before said, it's not a BIM guy who will do this for you. You have to change to use BIM to eliminate waste, to make it more efficient, make modules outside, fabricate outside. We tried to do some pods outside, prefabricated steel, prefabricated toilets and kitchens, and put them in place, which helped a lot, and show a benefit and the value added to the client and to ourselves.
Okay, so what essentially you're alluding to is kind of a client need to mandate lean project execution, and should have an eye on the waste and should use BIM as the technology enabling that.
No, what I'm implying that, like the gentleman before also mentioned, it's the integrated project delivery. Mm-hmm. That's, I think, the future. The client has to understand that he should bring the experience, the qualified contractor in during the pre-design concept even, okay, to make sure that the delivery or the value which he wants from his project is being implemented the most efficient way and with the cost effective. You fix aluminum facial or cladding, it can be fixed from inside, for example, instead of outside. It can reduce a month in the project.
But all of that requires a lot of pre-coordination in BIM and a lot of client involvement to enable those decisions to happen.
Absolutely.
And the alternative procurement method, which might affect the construction time frame, and certain decision making. Well, I think we'll get to that after this first round in terms of how we can change the process that we're typically following on as we execute projects to enable us to leverage BIM in fabrication installations. And we'll move on to Suhail from Autodesk. He's been on a panel before, so you've introduced yourself as a software provider. And I want you to focus on this. Why haven't we already revolutionized installation and fabrication in BIM? And what do you think would be something that a software provider needs to do to enable that to happen?
All right. So from the introduction perspective, I work for Autodesk, and I'm responsible for consulting services across Middle East, Africa, and Turkey. Predominantly really helping the large enterprises to make this transformation shift. That's what I am goaled on. Now, coming back to your question, I think why it hasn't been adopted is predominantly because it's still seen as a cost than a benefit. And there are several aspects to it. One of the first aspect is the model is still not considered as a legal deliverable. So if a prefabrication consultant or a contractor builds this model, he still has to produce the 2D stuff to get their approvals in place, which is like duplication of the work and it's the additional cost. Then having the pool of resources who can do it. So as of today, like gentleman said here, they are seeing some benefits when they are doing it for themselves, but as a project is not seeing the benefit because it's not coming from the client aspect. Then there was another aspect was the level of detail and the capability of the tools to handle these highly detailed models and avoid the repetition. Tools were not ready, or tools were ready, the hardware was not ready, or the cost of the investment was very high. With the democratization of these tools and this hardware now being easily accessible using cloud computing and all, I think that gap is now narrowing down. So we should be seeing some of the things like in the round 2, we'll talk about that more. So these were the contributions which were making this as a cost for the contractors who were in the prefabrication space. Then again, if I build this model, I assembled it, I'm ready to do this, but site people were not ready to consume it. They still needed 2D drawings to really assemble it and install it. It doesn't make sense. So how do we narrow that gap, make sure this information model is accessible or reachable to the site team in their language, their way of doing things, that they don't have to open 7 drawings to assemble or install. They can just open one model and really see the installation instructions right in the model and reduce the time of the installation. So these have been few contributions, the hardware, the software, the additional work which was seen as a cost than a benefit. the more and more we see it as a benefit. And I keep on saying every conference, never and then, we shouldn't be doing BIM for the sake of, like you said, cool 3Ds. We should be looking at it. It has to save $1 or make $1. Then only we should take. Because when you have this end in the mind that I want to do BIM only to make $1 or save $1, you will question the whole workflow. How do I save that? That will question, am I going to save on time, quality, cost? Then it will really remove those barriers, and you will have something more credible approach to it.
And what do you think a software vendor, and particularly yourself within the consulting arm of that vendor, can do to help? And you mentioned something important, that people on the site can't consume what's being created with BIM. So what things do you suggest, either a process approach or a software approach, that can help them disseminate that information?
I think we have started seeing last 2 years now a lot of these cloud computing solutions coming out from each of the technology providers, where a construction professional can really look up at on an iPad. I have been to a few construction sites which were very impressive. They have got big screens, and it's like, what is this large screen doing on the construction site? And they say, well, we have some drawings. Rather than going for 20 drawings here, I can just swivel this model and query and bring in this supervisor was bringing every complex installation, his team together, and explain the whole installation on the large screen, and then everyone goes back and just does it. So we as technology providers, we have a responsibility of bringing you those tools which are going to make it easy and remove those barriers. But as an organizations, you have to bring in those people and help them develop. And this should be part of the process, that enabling and bringing this information. As from the software perspective, we have been bringing these tools. I'm not saying they are best of it yet. We have still a lot of work to do on that side. But they are there today to consume this beautiful asset of information back in offices right on the site. And we're not talking about huge costs today. They are running on cloud, so you can run them on TVs and big monitors, or even simple mobile device, which every guy has today on the site as well.
So in essence, with now everyone being connected, with the information being ported to the cloud, it's easily accessible.
It's easy accessible.
The hardware is not an issue anymore like it used to be. The accessibility of the information is not an issue anymore. Now it's, I guess maybe we'll discuss, as we discuss the process, just making that time to disseminate that information on site.
Absolutely. You know, if I would have told you 3 years ago that a huge residential tower or a big infrastructure asset, you would be able to look at that in a mobile phone, it would have sounded like a science fiction. Today, it's just there. You can open a huge tower in a mobile device and look it up from your perspective, if you are fabricator, installation, or even simple installation of ductwork or firewall. So,
thank you, Suhail. Sachin?
Let me introduce myself first. My name is Sachin Singh, and I work as a project coordinator and also as a technology strategist at Archcorp Architectural Engineering, which is basically a multidisciplinary design consultant. To come to your question, there is a big fundamental difference in the construction industry and the other industry. The other industry, for example, if you talk about Toyota, they have to manufacture the same car probably millions of times. They have to operate in the same factory-like settings. But when it comes to our industry, it's totally different. I cannot replicate a same building which is fabricated on one side to the other side. And also, every job site is different. The conditions are different. So there are a lot of challenges which is existing with our industry when it comes to fabrication and applying all those manufacturing techniques which has been used by other industry to the construction. The second point I would like to mention is, I think the contractor should be part of the design process from the very beginning of the project, because that way only we can basically strategize the manufacturing, the fabrication part. Because when it comes to the architects, they will focus more on the design deliverables. They won't focus on how this design will be basically transitioned to the construction and ultimately the last phase, which is the facility management. There is also a third point the construction industry, if you look at it, currently, more of the architects, they are designing like straight shapes. When it comes to, when we are going more into the generative design, like the solution which is already there from the Autodesk, like the Dreamcatcher, and there, like Suhail mentioned in the last key panel discussion, that the artificial intelligence is the next big thing to come. Now, think about a scenario when the construction will transform from a straight shapes to a more fluid shapes, maybe the parabolic form or the hyperbolic form or any of these. Those times when it is really difficult to construct a design by humans on the construction side, the contractor will see actual value of this, the fabrication in a factory-like settings, so that they can fabricate the BIM fabricate the building object back into the factory, and they can basically come to the site and assemble it.
Okay, so essentially you're saying, and this is a topic that was mentioned earlier, contractor involvement early on in the project. And you mentioned something very interesting, and it's something that if you look at the productivity of the construction industry, it's nowhere near the productivity of the manufacturing industries, because we deal with atypical projects. Everything is unique. Everything is designed uniquely for that client, for that plot, for that climate, etc. And the time expected to deliver that project, whether it's the design phase or in the construction phase, is quite limited. We don't do prototyping as much as fabrication, or sorry, as the industrial, the manufacturing industry does. Sorry. So that's actually a very interesting point, because BIM is supposed to be able to enable us to digitally prototype our projects. But the question remains, is it something that we are accommodating as part of our design and construction process? And is something that, I think, Samer, you mentioned, is the client aware of that? Is he appreciative of that? Move on to another contractor, EngineeringSuhail with Drake Scull.
Hi, my name is EngineeringSuhail Gokulam. I work for Drake Scull as a BIM manager for the company. Been in the industry for last 17 years. So I've seen like from 2D to 3D transformation. We have embraced BIM for last 7 years. We have been associated with some of the major BIM projects in the region. And also, after 7 years, we still have a lot of challenges, like educating people, getting this information of the model to the the people who actually install services at site. So we are a MEP contracting company, and we have like most complex services. We have like 17, 18 trades and certain projects, especially like hospitals like Cleveland Clinic, or museums like Leo Museum, and the recent projects, one of the theme parks coming up in Abu Dhabi. So we have to do a lot of coordination. Like, it's not like straight walls. We have like services which are like 25 mm size, to services which are like 6 meter by 4 meter size ducts. So BIM has really given a lot of benefits, and also it is painful to develop a coordinated, well-engineered model, because there's more time required than normal traditional 2D process, wherein you discover many issues at site, and we spend, engineers and coordinators spend a lot of time at site trying to resolve these problems. But these all problems are now in the engineering office. A detailed, well-engineered model is like, saving a lot of material wastage. We don't have abortive works at the end of the project. Like we are commissioning, we discover a lot of issues. And also we are we have our own 3D scanning facility. The model is always kept live, and within 2 or 3 days we update whatever we install at site. So in that way, even if there is a change to be done, either it's been initiated by a contractor or by the client, we know exactly what is there at the site at this point of time, and judgments can be more accurate. Rather than you guess that, okay, you make a change request, and then we identify that it's going to have a much more impact than what we thought, when we were making such decisions. So decision making is much more easy, especially for Drake Scull. We have up to foreman level people are now having access to the 3D models. So they go and review the model before they go and build it. So it saves a lot of time, everybody knows, like, they have to be more disciplined. Like, there is a space for your service, you need to go and install the services in that particular point, not in another different location, and then it causes a clash at site. So for Drake Scull, as an organization, we are going to, do more and more projects in BIM, because it is giving us a lot of advantage, especially in the materials. The wastage has been reduced. I will not say it is zero. Still, we make some wastages of ducts and fittings and all, but still, it's been reduced to considerably reduced.
Okay, so one interesting thing you mentioned is scanning and adjusting the model. So reality capture is something that needs to be taken into account to enable, to leverage BIM really for installations and maybe off-site fabrication. Can you elaborate on that point as well, and how you would integrate reality capture of, say, the civil works that's handed over to you before, as an MEP contractor, you would go in and install?
See, the project which I'm working on now, like this is the first project we are using 3D scanning. So what we do is, like, once a civil contractor builds a, say, shear wall or a slab, it's been casted, it's been scanned by the civil contractor. The models are being updated. Before we are given access, we go and do a check whether this is causing us any clashes or any deviations are there. Normally we find problems with block walls, it's moved like 100 mm, 50 mm, sometimes 200 mm. So these kind of changes will have an impact on the MEP coordination, which has already been done. So then we do a minor adjustments wherever it's required, and it helps us rather than even though it is as per we are following as per the model, but still site conditions are not matching to the design. So it helps us. So
you do adjust your model to coordinate it again with the as-built conditions that you've just measured from a laser scan or other means. How doesn't that affect your final output before you go and install, which could be a drawing, which might need an approval, etc.? How has that affected that final output?
So we have put like a workflow in place wherein any changes, like all the walls are not going to be having discrepancies. Like we definitely keep some tolerances, like some changes within 25 to 50 mm, which we can ignore, and that's not going to cause problems. But major changes are notified, and it will be like reflected in the drawings. So we re-extract the drawings and issue it to the site.
Thank you so much. And last but not least, Chris from KEO Insight, you might think that he doesn't have a lot to contribute as a landscape architect, but I think if you think about landscaping being an issue that clients always are particular about before they open a project, and something that might take a lot of time and cost, actually, you'll be surprised at the percentage cost of a project. There's a lot that we can leverage from landscape and BIM, and Chris can maybe share his thoughts on that.
Yeah, I help with the implementation of BIM within KEO, but I specialize obviously in landscape. When we look at fabrication within landscape and how the BIM process will help it, I think at the moment implementing BIM is the key thing, because landscape can still be dragging its heels behind at the moment because of different factors, mainly skills within the industry and software capability of being able to do what we need it to do. So when it comes to leveraging fabrication, I feel that people aren't even looking at that yet. They're not looking at where fabrication within landscape can really help reduce waste and help with the speed of a project. They're more concentrated on trying to figure out how they're going to implement it first. Now, the benefits of using BIM systems to help us when it comes to fabrication is, well, they speak for themselves. I mean, we have done fabrication in the past where we've had big interactions with the building, but the fabrications that have come from landscape have come for 2D drawings. So even though we prefabricated off-site, when we get on site, we realize it doesn't fit. Or certain aspects of the building haven't been coordinated properly because we've never had the skills to federate the models. Now, these are skills that are now being proven, and the industry is now starting to come online with. As well with the movement of materials and helping with the fabrication of a building. Building your model for the entire landscape can really help with the maneuverability of around the site, and also helping with reducing costs, not only for like the quality of what you're building, but also for even to the stage of like yellow, your yellow diggers, and the to make sure you're reducing waste of where those like the routes between your materials and where they need to be, and also just the organization of your materials on site to make sure that there's no damage and they're easily accessible.
Thank you so much, Chris. I would like to summarize the key themes or and maybe the end result of what we'd like from leveraging BIM in fabrication installation. Reducing wastage, reducing time to install, eliminating or minimizing rework, and something, Chris, that you just mentioned is ensuring access. Now, I've been informed by the organizers I've got 5 minutes left. So I just wanted to touch on something that maybe we didn't really, or we alluded to, but we didn't really go into in depth about, is the changing our ways of working and the processes. And we've got clients, contractors, designers, sometimes specialists, consultants, or subs involved in a project. Uni mentioned that you do reality capture, you change your models accordingly, and usually that would mean your output, your final output, a drawing, or if you've agreed that a model is going to be shared with a consultant, it's something that needs to be reapproved before you can go and execute on site. Sachin, you're with a consultant here. Is it something that you would accept in terms of express approval of drawings or models? When you review a drawing, say a shop drawing, are you focusing, or can you conditionally approve it that I am okay with the installation of the systems shown in the shop drawing, however make sure the following dimensions are maintained, or this is the maximum allowance or minimum allowance of certain dimensions, so that as reality of what has been installed on site in terms of preceding work, could be civil, could be other MEP services, is captured, and the model is updated and new drawings produced, there's no need for that reapproval, lengthy approval process to take place before a contractor can go out and execute on site. And this can build into, Mohamed, you mentioned artificial intelligence and predetermining what's key factors or key dimensions, their minimum and maximum, or if they have to be a certain number. Is that something that you think we're getting to? Mohamed, we'll start with you.
Yes. I want to talk about one of the examples that we have already faced, because usually case studies is better than talking about theoretical things. So one of our projects is Boulevard Point by Amar in the downtown. And in one stage, the consultant decide not to put threshold. So this was impacting the fabrication and the installation of the tiles, that we had a lot of cut pieces. And this was like a tremendous pressure on all people, especially the main contractor, that he will cost a lot of money in wastage. So we had come with the idea to use scripting to apply wastage control in the cutting the tiles itself, because in the normal practice, the installers will cut the tile and the remaining they will throw. So our idea was to first to scan, 3D scanning, all the wet civil work, the concrete and the block work, that could make us very sure that we can make a prefabricated and pre-cut the tiles with lasers. And then we had to scan we applied this for only one floor just to show them how much we can save from the wastage. And we started to scan the whole floor. Then we applied some algorithm that marking the tiles and collecting all the cut pieces to collect a whole tile, then marking them using grasshopper. Then we send this for CNC or laser cutter that cuts exactly the needed part after adjusting the fabrication model with the as-built model. So we made sure that the cut piece will come to fit in its place exactly.
So, because I'm conscious of time and the ladies there are telling me I should finish. So let me propose this to the panel and to one individual in the panel. So if the contractor said, I've done a laser scan, I've written a script or just a parametric program really, and I can guarantee you that everything that you've requested in your specs, the minimum cut sheets, etc., will fit. And do you need a drawing still at that point? And why would you need a drawing? And would you be able to review the model, or would you just, we don't even have to model it if it's been
Mohamed, can I say
programmed in
something
Script?
Coming back to the same thing which I started. The IPD is the solution for this.
Okay.
The consultant, I can answer for you. And he's not going to agree to it because he did not see it. He did not see the mock-up. He did not see the sample. While if it's an IPD, it's a
Everyone's in the game.
This
You
is
share
what
the
we
pain,
do
you share the
also
gain.
in engineering and ECC. We convince the client that let's shift this to in-house. And we assure you we'll increase the value, add a floor or something in the same time and with the same cost. But that has to be taken in-house or in a one entity or in a collaboration. That's, I think, the solution.
So I guess as we're working with BIM technology, but we still have these contracts in place where we need to sign off responsibility, limit liability, and indemnify each other. That is limiting our ability to leverage BIM to enable us to quickly design, install, to minimize wastage, to reduce rework, and also to probably get ourselves, ensure that we get access to the areas that we need to install. And is that correct, gentlemen? Suhail, do you have something to add?
Yeah, I just want to add quickly. I think what he correctly said, how would we know, how would we approve? I think this is the time when simulations will come to play. More and more fabrication and installation has to be simulated and pushed onto the client. Let them experience it. Let them see how they are saving time and wastage. And today, some of our clients are doing it. And going forward, I don't see that day very far when half of this job will be done by robots. So that's going to bring additional time savings there.
Any final thoughts from our panelists?
If you ask me, I hate shop drawings. When it comes to approving a shop drawing, you have to look through various different things. Why I can't have a shop model rather than a drawing? So that I can look the design in its entirety rather than just looking at one piece of the shop drawing and forgetting about the other things. If I can have a shop model, I can see the design in the entirety. I can tap to an element and I can look through what kind of finisher it is. I can do all those data mining to validate the design, whether it is the same as per our design intent. That will be the future, I guess. Okay.
Any other thoughts from the panelists?
See, actually, as contractors, we go quite detailed into, we have an IFC, and from the IFC design documents, we develop the model, we engineer it, and then once this is engineered model is given to consultant, normally the reaction from the consultants are, we are not interested to review the models, we will review your shop drawings. So that's a very common, I mean, I've worked with most of the consultants, I mean, I don't want to name anybody, but that's because they are interested only in the shop drawing. But if that approach is changed, they start reviewing the model before they approve the shop drawings, and all the model, we maintain the sanctity of the model. We extract only from the 3D coordinated or engineered models, and the shop drawings matches exactly what is there in the model. Actually, the consultant should actually look at these models, approve the models, and then it makes contractors' life easy. Okay, and sometimes the comments we receive at the extracted shop drawings are the last phase of the engineering, and we have to go back, recoordinate, and change the models to meet their comments.
So we've essentially reached the conclusion that it's not the technology that is that needs to be leveraged. It's really just our processes and the contracts that need to be rethought in order to leverage technology for installation or speeding up installation, minimizing rework, and prefabricating our projects. I think that concludes our panel discussion. Ladies and gentlemen, I'd appreciate if you can show your appreciation for the panelists.
Thanks.
Thank you so much.